Hello everyone, this is our product examination video for the Whitwood GP200 calipers. Let's get started. First off, we're going to talk about the caliper halves. We know that they're machined out of a CNC mill, then anodized later to present corrosion resistance. The CNC mill allows us to have precise dimensions and also complex passageway for the fluid. We know that this is not casted because there's no, all the surfaces are machine surface. This also increases the strength. We could cast them, but we'll still have to machine it after to define the exact dimensions, and due to the product's sizing and quantity, it doesn't make sense for this process.
The next part that we're going to look at is the brake caliper piston. In the middle, you can see an image of our particular brake caliper piston, and on the right, there's the piston's position in the assembly. When the brakes are applied, the brake fluid pushes the piston into the brake pads, which presses onto the rotor and stops the car. Our particular piston was manufactured using stainless steel, which was first cast and then machined to precise dimensions on a lathe. It is possible to fully machine this part, but in this case, it was done by casting and then machining.
The next part we're going to look at is the piston seals. The piston seals are used for maintaining hydraulic pressure and preventing brake fluid leaks. The typical material for piston seals is EPDM, and the manufacturing process for that is compression molding. Some of the benefits for compression molding are strength, minimal waste, appearance. They're cost-effective and can use recycled materials. Cons would be high manufacturing costs and slower processing times. Alternative manufacturing processes would be transfer molding and injection molding.
Next, we're going to talk about bleeder screw, and they're usually found on top of the brake caliper, and their use is to release trapped air in the brake fluid to ensure proper hydraulic pressure. They're usually made out of steel or brass, which offers strength, corrosion resistance, and sometimes coated with zinc to enhance durability. Manufacturing processes for these are usually CNC machining to ensure precision threads and dimension for tight sealing. Also cold forging, and it's common for mass production, adds strength to the material through deformation without heat. You've got pros like high strength, corrosion resistance, and precision. Cons is it's limited in design. And also sometimes CNC processes are slow for mass production, so it's not very viable. Also, alternative processes would be power metallurgy and additive manufacturing, which is 3D printing.
The bolt used in this brake caliper system is a socket head cap bolt. These bolts hold caliper halves together and provide rigidity to the braking system. The stock head cap screw is an ideal option for the braking system because of its confined space in the braking mechanism. It allows easy installation and removal in tight spaces in braking system. It's made of steel to provide better strength as well as it's more economical to manufacture. The manufacturing process includes thread rolling, hexagon puncher to create hex socket, heat treatment to increase durability, and chrome plating for hardness, corrosion resistance, and aesthetic appearance. Some alternative process could be broaching for screw head, thread, lathe, and metal casting.
These are our references, and thank you for our presentation.